Okay, so we'll just do some questions rather than just talking about concept. If you look at the next page of your question, you have a force of 100 Newton that's applied to push a 5 kg block forward. The block experiences a frictional force of 13 Newton as it slides. Determine the acceleration of the block. So right now you have a block of 5 kg. You apply a force of 100 Newton. You're interested to find out what is the acceleration of the object. So this one is easy. You can just say that Fnet is equals to MA. Your Fnet now is just this one. It's just going to be 100. Your mass is 5. Then your acceleration is just going to be 100 divided by 5, giving you 20 meter per second squared. Okay, so this is a simple application of Fnet equals to MA. So this one is okay. Now, what if you have the same block, a similar block, not same block, that's being pushed up and inclined instead, rather than a horizontal surface? And now we ask you to find the acceleration of the block. Okay, so now you have a block of 15 kg that slides down an inclined plane of angle 30 degrees to the horizontal. It experiences a friction of 25 Newton. Determine the acceleration of the block. Okay, so I think the first example should be quite straightforward. I'll just rub off the first example. I'll just clear this one. Okay, now, before you proceed with this, you need to identify how all the forces acting on the block. You need to produce the free body diagram of the block. Just now I told you free body diagram is the forces that show, is a diagram that shows all the forces acting on the object. So right now we want to produce the free body diagram acting on the block of mass 15 kg here. So the first thing you could probably say is that there is a weight equals to mg on the block acting downwards. Now from here, you can do something else. You can actually resolve the weight into two components. You can resolve it into this direction and this direction. Okay, the weight can be resolved into two perpendicular components. Okay, it can be resolved into two perpendicular components. One is parallel to plane, and then another is perpendicular to plane. Okay, this weight W can be resolved into two perpendicular components, which is this one and this one. They're both perpendicular to each other. Okay, so one of them you will notice is parallel to the plane. Another one you will notice is perpendicular to the plane. Okay, the plane that I'm talking about is this blue colored line here. Sorry, let me just revert this. It is this blue colored line here. Okay, one of it is parallel to the plane, one of it is perpendicular to the plane. Okay, now usually when you resolve it into these two components here, you are interested in finding out what is the expression for the components. So what we will tell you now is that this angle here is always going to be theta. Okay, I can prove to you why is it theta, but let me just redraw another diagram here so as not to interfere with anything. If you say that there's an angle theta here, and then you say that you have a block here, it makes a line like this, and then you have another one like this. Okay, maybe I should extend this all the way to here. Okay, maybe yeah, can extend all the way to here. Now notice that this one I mentioned to you is always going to be perpendicular to the plane. Okay, so this one is 90 degrees already. Now also notice that you actually have a triangle here. If you look at this side, and this side, you're actually going to form a right angle triangle. So if this one forms a right angle triangle, what you're going to have here is just going to be 180 minus 90 minus theta, giving you 90 minus theta. Okay, so this part here is 90 minus theta. Then another thing here also is this. You can actually identify another triangle here, which is this one here. See, this one is another triangle. Okay, but we already said that this entire side is already 90. Okay, actually there's two triangles. Wait, let me just draw this. There's actually two triangles. I use a different color. There's actually this triangle and also this triangle. Okay, so what you want to do now is this. You want to talk about this triangle instead. Sorry, you're talking about this triangle. Okay, this triangle here is actually another right angle triangle where this one is 90 degrees. Okay, so if you're interested in finding out what is here, you need to take this angle plus this angle, subtract it from 180. What do I mean by this is that this one will be 180 minus of 90 minus of 90 minus theta. Eventually you will get just theta. This is just going to be equals to theta. That's why here we say it's going to be theta. All right, so it's a matter of playing around with the triangles. But again, this one is just something like a derivation to understand why this is always theta. It will not be tested in your exams. Just know that it is usually theta here. If this one is theta, this one will also usually be theta too. Okay, so that is one thing here that you can do. All right, so this one is theta. Now, from here, you can now work out what is your expression for your angle, for your components, for your the components for your weight. You see this angle, this component is adjacent to your angle. So this one will be mg cos theta because it's adjacent to your angle. If this component here, you shift it here to complete the triangle, it will be opposite to your angle. So this one will be sine. So this one will be mg sine theta. Okay. So mg cos theta here, mg sine theta here. Okay. Then after that, your question mentioned this. Your block is sliding down the plane and experiences a friction of 25 Newton. You're moving down. You have an acceleration downwards. But at the same time, when you're moving downwards, you experience a friction of 25 Newton. So right now, you have another force here of 25 Newton. Okay, so now this is your free body diagram already, which shows you all the forces acting on your block. Okay, no doubt you also have a normal reaction force here, but we don't bother about it because it doesn't contribute to your motion right now. Okay, so we just consider this one. All right, so right now the question just wants you to find out what is the acceleration of the block. Okay, so Fnet is equals to ma. The Fnet here will be mg sine theta minus 25 equals to ma. So the few things to recognize here is only consider the forces, only consider the forces along the direction, only consider the forces along the direction of A, positive, then this one I will just say that force is positive if in same direction as A, negative if opposite direction to A. Okay. So right now I want to find the acceleration. I want to use Fnet equals to ma. I know that the block is sliding down along the plane. Its acceleration will be along the plane like this. Okay. In this direction like this. So when I want to find out the net force that causes the acceleration A, I must only consider the forces that are along the direction of A. So you only take forces that are along the direction of A. Meaning to say you only take the forces that are diagonal, parallel to the plane. That would mean you only consider mg sine theta and the force of 25 Newton. You won't consider mg here because they're not along the direction of the acceleration. You won't consider mg cos theta here because they're also not along the direction of the acceleration. You only consider mg sine theta and 25. Okay, and then from there, which one is going to be positive or negative? You just see which one is in the same direction of A. The force will be positive if it is in the same direction as A, but negative if it's in the opposite direction to A. The only one that seems to be in the same direction of A right now is mg sine theta. The one that's opposite to A is the 25 Newton. That's why you get this result here. Mg sine theta minus 25 equals to ma. Okay, so from here, all you just need to do is to start subbing in the value. 15 times 9.81 sine 30 minus 25 equals to 15a. So a will be thus be equals to 15 times 9.81 times sine 30 minus 25 divided by 15. You should be getting 3.24 meter per second. Okay, right. So we continue on with the next example. You have two bodies X and Y that are in contact and placed on a frictional surface. A horizontal force F of 12 Newton is applied to body X, which in turn pushes body Y. If the mass of X is 6 kg and the mass of Y is 3 kg, what is the acceleration of the blocks? And what is the force that X exerts on Y? Okay, your block X is 6 kg, block Y is 3 kg. So right now, they want you to find out two things, the acceleration of the block and the force that X exerts on Y. Okay, now, if you consider this system consisting of block X and block Y, it will have an acceleration A. Okay, so this one, you can just think of it as free body diagram of the system. Okay, the system here consists of two blocks, X and Y. Okay, you're considering as a group. Okay, you can break it down into something smaller into the individual blocks. But right now, I'm just considering it as a system of blocks. Okay, so right now, this is the free body diagram of the system. There's a force F of 12 newtons. Okay, and then there's mass of 6 kg for block X and 3 kg for block Y. Now you want to find the acceleration of the blocks. Okay, so the blocks here would imply acceleration of block X, acceleration of block Y. So here it's important to know that the acceleration of either block X or Y is the same as acceleration of the system. What I mean by that is that if let's say I told you A is 2 meters per second squared for the whole system, obviously block X itself will also have an acceleration of 2 meters per second squared. Block Y will also have an acceleration of 2 meters per second squared. It cannot be a case where the whole system is moving at 2 meters per second squared, but this one is moving at 4 meters per second squared, and then this one is moving at 3 meters per second squared. It doesn't make sense. If you already find out that the whole system moves at a certain acceleration, everything will be moving at the same acceleration. Or if you want to have an easier time of visualizing what I'm saying, I could be telling you that maybe your whole system was moving with a velocity of 10 meters per second. So obviously block X and block Y will also be moving with the same speed. It cannot be, I say the whole system is moving at 10 meters per second, but then this one moves with 5 meters per second, and then this one moves with 20 meters per second. It just won't make sense. They must all move with the same speed or acceleration. Okay, so right now, if they say what is the acceleration of the blocks, it is just enough to know that the acceleration of the system itself will be equals to the acceleration of either block. So right now, if I consider the free body diagram of the system, where I say considering the system, I will say that Fnet is equals to MA. Okay, this is the general equation. Right now, my Fnet is just 12 equals to 6 plus 3A, which will give me A equals to 12 divided by 9, giving me 1.33 meter per second squared. This will be the acceleration of either of the blocks. Okay, bear in mind there's no other forces acting on the system here. It's a frictional surface, so no friction to consider. Now the question then asks you, what's the force that X exerts on Y? Now this is where you will need to break down the blocks into individual objects. So if the first one was you considering the system. The second one will be considering individual blocks. Okay, if I consider individual blocks, block X would be something like this. Okay, where you say that there's a force of 12 Newton acting on it, and then there's also another force acting opposite to it. There's another force acting in the opposite direction, which is this one. This is force XY. You see, when your blocks were being pushed to by the 12 Newton force, block X would hit onto block Y, exerting a force of Fxy onto block Y. But recall that Newton's third law tells you that if you exert a force on one object, there will be an equal opposite force exerted back on the other object. So you will have another force Xy exerted on block X itself. Okay, so let me just redraw this myself for you. This one would be Fxy. Okay, so when you use the 12 Newton force to push onto block X will in turn push onto block Y, causing you to have this force Xy. And in return, from Newton's third law, you will also have an equal opposite force of Fxy acting back on block X. So this is the free body diagram of both those systems, or both those blocks right now. Okay, and they will all both move with the same acceleration of A, which is 1.33 meters per second that you've just found. Okay, So this is the free body diagram of the blocks. This is showing you all the forces acting on the individual blocks. Okay, they are separate. All right. So right now, what you want to do is you want to find fxy. You can either consider block X itself, or you can either consider block Y to find fxy. You will still get the same answer. We will try out both. Okay, so if necessary, I say for block Y, I know Fnet is equals to MA. This is the general form of equation. Fnet equals to MA. This is the general form of the equation. I will say that is Fxy equals to 3A, which is 3 times 1.33, giving you 3 times 1.33, giving you 3.99 Newton. Okay, so this is if I'm talking about block X. Let's see whether if we consider, sorry, this is if I'm talking about block Y. Let's just say if I now use block X, would I get the same answer? If I use block X, again, I use Fnet equals to MA on block X itself. The resultant force on my block X would be 12 minus with Fxy equals to 6 times with 1.33. So Fxy would thus be equals to 12 minus 6 times 1.33, giving you 4.02 Newton. Okay, now this one, if you round it up to 2SF, you're going to see it's 4.0 Newton. And this one, if you round it up to 2SF, it's actually going to be 4.0 Newton. So they're actually the same. At 3SF, yeah, the answers seem to be slightly different, but at 2SF, the answers are exactly the same. Okay, so right now, to find the force Fxy, you can either consider either block Y itself or either block X itself. So long as you properly apply the Fnet equals to MA equation, you will get the same answer. Okay, so this one here, your Fnet is 12 minus Fxy. 12 Newton will be the positive one here because it's in the same direction as your acceleration, whereas Fxy will be negative because it is in the opposite direction to your acceleration. But when you move on to block Y, Fxy is in the same direction as your acceleration, so it's just positive. That's all to it. Okay, so this is how you solve to find this answer. So if nothing else, then I move on to the next example. This one is something else. This one concerns a pulley, if I'm not mistaken. Okay, now if you move on to example number 4, yeah, so just now the previous question, you use either method lah, either for block X, for block Y or block X. Just use either one. Okay, you don't need to do both lah if you don't need to. Okay, right. If we move on to example number 4, your diagram shows block A of mass 5 kg and block B of mass 8 kg, which are connected by a light inextensible cable that passes over a smooth pulley. Okay. Sorry. That passes over a smooth pulley. Assuming that the surface and pulley is frictionless, determine the acceleration of the blocks and tension in the cable. Okay. So what they want is acceleration of the blocks and the tension in the cable. Okay, so now we can do something again where we identify all the free body, the forces acting on the system. Right now, we say that the block of 8 kg, it would have weight. Okay, now, right now, over here, your block 8 kg would have a weight of W let's just call this, yeah, this one is block B lah. Okay, this is block B, this is block A. Okay, this one has a weight, and then you have a normal reaction force. Okay, then this one, they say that the surface is frictionless, there's no friction acting here. Now, but this block is connected to a cable, this cable here. Now, the cable itself will exert a force onto the box. So, if you just consider the cable, all right, because this block is moving down, the block is moving down, it's actually trying to, this block is moving down while this block is resting on the table. It's actually trying to extend the cable. So if you look at the free body diagram of the cable itself, maybe I use a different color for the cable. If I look at the free body diagram of the cable, there will be something like a force that is trying to stretch the cable. Okay, that force is known as your tension. Okay, but now if I consider only the forces acting on the block, this one is your block B, this one is your block A. Okay, so you see there's a force that is being exerted on the cable here. There will be an equal opposite force on the block. So if there's tension T here, there's also going to be tension T in the opposite direction here. Likewise, for block A too, if the cable here has tension T, the block A here will have an equal opposite tension T. Okay, so this one is a consequence of Newton's third law. All right, so you're just considering only the forces on the block, not the cable right now. The forces that I'm labeling here is only for the block. Okay, there's a tension T here. All right, this is the free body diagram for block B. If I look at the free body diagram for block A, I can say that there's the weight of A, and then again, there's tension T. Okay, so what I have labeled here is just the free body diagram of the blocks. Okay, I did not label the free body diagram for the cable. If you're talking about the free body diagram for the cable, it's just looking like this. It doesn't tell you anything useful, so I'm just gonna omit it. All right, so these are the forces acting on your blocks right now. Now, when you have the block and you release it, this block A will pull down block B. It will drag this block across the table while this one goes down. All right. Now, because your both blocks are connected by light inextensible cable, both blocks experience same A. Okay. So when your block is falling down in one end and then the other block is being dragged across the table, they both experience the same acceleration of A. So this one will have an acceleration A downwards, and this one will have the same acceleration A towards the right. So right now, what you're interested to do in doing is to find out what is the acceleration A as well as the tension of the block. This one, you will need to use something like simultaneous equation. So what we will say is that I can say that if I try to draw it out nicely for you for block B, I have tension T, I have acceleration A. And then for block A, I have weight of A and then tension T. Now, I won't consider the normal reaction force and the weight B here because none of these forces are in the same direction as my acceleration. So I don't really want to bother about these forces here. So I can actually just ignore the weight of B and the normal reaction force N. They don't do anything to the acceleration. I only consider the forces that are in the same direction as my acceleration, or along the same direction as my acceleration. So this is the proper free body diagram that I want to use. This is the free body diagram of the blocks. Okay. So now if I'm talking about for block B, I know that Fnet is equals to MA, the general form of the equation. I will say that T is equals to 8A. This is equation number 1. Okay. And then for A, again is Fnet equals to MA. So I know that the acceleration is downwards for this one. So when I want to make out the equation for Fnet, which of this is positive? Is WA positive or T positive? You look at the one that's in the same direction as your acceleration. In your case, the weight is in the same direction as your acceleration. So it's actually just going to be WA minus T equals to 5A. The weight here is 5 kg because the question already told you that. Okay. So this is your second equation. Now, if you substitute 1 into 2, you're going to get WA equals to 8A, 5A. So you're going to get MAG equals to 13A. So mass of A is 8 times your gravitational acceleration 9.81 equals to 13A. So A is going to be 8 times 9.81 divided by 13, giving you 6.04 meter per second squared. Okay, so now you have found acceleration, but you still need to find the tension. If you want to find the tension, you just say from equation 1, T is 8 times of your acceleration, so it's 6.04. 8 times 6.04, you're gonna get 48.3 Newton. Okay, so this is your answer. This one you have to consider the blocks individually and then use simultaneous equation to find the answer. Now, some more advanced, some students would tend to think it like this in another way. This one is you consider by system, okay? This one is still correct also, just that it's not very rarely used. Now, if I consider as a system, when I consider as a system, I consider it like this. Okay, both blocks. So this one, if I consider as a system, I can say something, I can think of it as being similar to this. This one is block B. And then this is block A. Now, when I consider as a system, I think of it as, imagine the blocks as being laid flat and moving in one direction. Okay. Now you see, if my block is moving downwards here, and then this block is moving in this direction here, if you imagine both blocks are now laid flat like this, your overall general direction is just going to be towards the right with an acceleration of A. Okay, so the only forces that will be acting for you is WA. Okay, this is another way of doing the same thing. Okay, this one here is if you consider the whole system. But when you consider it as a whole system, you imagine the blocks as being laid flat and they're all moving in one direction. Okay, this entire thing, you imagine this one as being pushed outwards so that it's now flat, then you imagine what is the direction that they will move. They will generally move towards the right with an acceleration of A. Okay, so what's the force acting on the whole system? Previously, you would have said that, okay, here you have tension T, here you have tension T, like this here, right? But you see, they are equal opposite. They actually cancel off here for the whole system. If you consider for the whole system, the tensions cancel off, so it's actually not something you want to consider. So the T here is not inside. You won't consider the T. The only force that you see is just this, and it's moving in this direction for your acceleration. So if you use Fnet equals to MA, your Fnet is just WA equals to your masses, equals to your mass times your A. So over here, what we have is WA, wait, let me just rewrite this. This one is just going to be MA plus MB times A. So this one will be MAG, MA plus MB times A. So this one would be 5 times 9.81 equals to 5. Yeah, 5 plus with 8A. So A, you will see, is equals to 5 times 9.81 divided by 13. Wait a minute. Did I do something wrong? Which this block is A? There's something wrong with my working. Okay, wait. 5 times 9.81 divided by 13 is equals to 3.77 meter per second square here, right? It looks slightly different from what I have here, right? The reason is because I substituted something wrong in the original equation. If you just look back at this line here, I say substitute 1 into 2, WA is equals to 8A minus 5A, so MAG is equals to 13A. Okay, the mistake that I have here is this. This one is not 8 kg. 8 kg is for mass B. I want mass A. Mass A is 5, so the mistake was this one. Okay, so this one, I'll just change this. This one is 5. 5 times 9.81 divided by 13 is going to give me 3.77 meter per second. Okay. Meter per second square. Then if I correct for this one would be 3.77. 8 times 3.77, you're gonna get 30.2 Newton. Okay, so there's nothing wrong with this working. It's just that I sub in the wrong value of mass. Okay, so the new T is 30.2. The new acceleration is 3.77. Okay, now this is the correct value of the acceleration. If you compare with this method that I use here, your acceleration is going to be the same as before. Okay, it's actually the same answer. This is just another different way in which some students tend to like to do it. They imagine this as a single system and that the blocks are laid flat and is moving in one general direction. So they apply the Fnet equals to MA here, they're still going to get the same answer as if I use the method where I separate all the blocks and consider individually. So it depends on you, whether you want to use this method on the left or the method on the right. The method on the left is actually quite fast to use, but you need to make sure you know your free body diagrams properly. Okay, so this is example number 4. Then we go with example number 5. Okay, right, the diagram below shows two blocks A and B of masses 5 kg, 8 kg respectively that's connected by light in extensible cable that passes over a smooth pulley. Again, determine the acceleration of the blocks and the tension in the cable. It's a bit similar to the cases now that we did, but the arrangement is different. This time is like this. You still want to find the acceleration and the tension. Okay, so same thing as before. If I want to consider all the free body diagram, there's actually the cable and blocks A and B. Now this one you can easily see that block A is pulling down on the cable. Block B is also pulling down on the cable. So the cable would have tension T like this. Okay, it's being pulled down. Okay, so your force acting on the cable will be like this. Then in return, on block A, you have an equal opposite tension here. And on block B, you also have an equal opposite tension here. Okay, so this is the tension acting on both blocks. Block A would have its own weight WA. Block B would have its own weight WB. So this one, if I were to draw your forces, this one would just be T. This one would be WA. This one would be T. This one would be WB. Normally, we don't bother about the force on the cable. We don't bother showing the force on the cable because it doesn't tell us anything useful. Okay, we only want the forces acting on the blocks itself. Okay, so right now, block A is 5 kg. Block B is 8 kg. This is the heavier one. This is the lighter one. So obviously, your block B is going to go down and block A is going to go up. So since they are connected by, again, a light inextensible cable, they will both experience the same acceleration. So this one, if I use a different color here, you have an A downwards and you have an A upwards. Okay, so now I want to consider the blocks separately. Okay, so I'll just say, let me just do this. I'll just say that for block A, again, if I want to use Fnet equals to MA, so block A was this. You had WA, you have tension T, and then you have acceleration outwards. So in your case here, it will be T minus WA equals to MAA. Okay, this one, let's just say this is equation 1. I don't sub in the value first. Then after that, I will say that for block B, again, I want to use Fnet equals to MA. But this time, for block B, it is something like this, where I have WA and T, but my acceleration is downwards. So this one would give me WB. Sorry, this one is WB. And this is for block B. So this one, I will say it is WB minus T equals to MB. This is equation 2. So now notice I have two simultaneous, two different equations. If you had this one alone, equation 1 alone, you will not be able to solve this to find A because you have another unknown. You had two unknowns here. You wanted to find A, but you also do not know T. If you had this alone, this equation alone, you will not be able to solve. So you have to have another separate equation so that you can use simultaneous equation method to find the variables. Okay, that's the reason why I also have to consider another block now. Because as it is right now, with just block A, I will not be able to find out the answer. There are two variables inside one equation. Okay, so now I have two equations. I can now actually work out and find out the variables. I can find out either A or I can find out either T. But let's just say I want to find out A first. You see this form of equation here like this, I can actually just say 1 plus 2. You see this is T, this is negative T. This is T, this is negative T. If I add them out, they will cancel off. So eventually I will just get WB minus WA equals to MAA. I'll just use a shortcut, MA plus MBA. Okay. So from here, let's put in all the values. Weight of B would be equals to 8 times 9.81. Weight of A would be 5 times 9.81. Then mass A plus mass B would just be 5 plus 8A. So what's the final answer of A that you get? 8 times 9.81 minus 5 times 9.81 divided by 13. You should get 2.26 meter per second squared. This is your acceleration A. So now if you want to find out what is your value of your tension, just use either equation 1 or equation 2. It doesn't matter which one you use. Maybe I just use equation 1. From 1, T equals to 5 times 9.81, which would then be equals to 5 times 2.26. So T, 5 times 2.26 plus 5 times 9.81, the tension will be 60.4 Newton. Okay, so this is how you find your answer. Now, if you want to use back like this other method just now, considering as a whole system, you can still get the same answer. So let's just say I write this somewhere here. Considering as a whole system. Okay, I consider this one as being laid flat or laid flat in one way or another. If I laid it flat in one way or another, it would actually look something like this. Let me just rub this one off. It could look something like this, where I tell you that it is B, and then this is A. In general, you're moving downwards. Okay, and then now you have two forces acting. You have WA, and then you have WB. Okay, now WA is acting this side. Sorry, WA is acting this side. Basically, what I'm doing here is that I imagine this one as being shifted outwards so that it forms a line. Okay, so in general, my direction would be going downwards. Okay, but my WA would not be acting upwards. Okay, that's why I did it like this here. Okay, then the tension T, as before, you will notice that they are actually acting opposite to each other. They actually cancel each other off, so you don't really need to bother about that. Okay, so these are the only forces acting. So you try to use Fnet equals to MA here. You will say that WB minus WA is equals to MA plus MB equals to A. So the workings is actually going to be the same. You see, this one is just going to be the same as this one again. You'll be getting back the same answer, A. Okay, you still be getting back the same answer because you see this one will be the same expression as this one already. Okay, so this one is if you consider as a whole system, you will still get back the same answer. But after that, you want to consider the tension, you have no choice but to consider either one of the blocks. Okay, to find the tension, you have no choice. You have to separate out into blocks and find out the tension individually. You consider as a whole system, you cannot find the tension. This one will only help you to find the acceleration. Okay, so this one is another method. Same as before, up to you which one you want to use. For me, I would suggest you separate it by block if you are not so familiar as a start. Only when you're very familiar, only then you start to use it like the ones I show here, when you consider as a whole block. Okay, so this is example number 5. Then we go to example 6. We record the lesson. Okay, the last lesson we stopped in page 5, on page 5. The examples, we did some of the examples on dynamics, so we start at page 5. There was another example left that is on page 6 that we did not manage to go through. Okay, so we'll go through that, and after that we'll go a bit more on collisions, then we do some examples. Right, so right now over here you have this case where, let me just try to do this. Right now over here you have a case where a person is standing inside an elevator as it goes through different stages of motion. Determine the apparent weight of the person during the following cases. Okay, now apparent weight is just the weight that a person feels due to contact with a surface. For example, feet with floor. Okay, so I can't see properly. Weight that a person feels due to contact with a surface. For example, feet with the floor. Okay, this is one thing here. Now, for example, when you're standing, let's just say right now you're standing, you can feel something when you're standing, some sort of force when acting through your feet when you're standing. That is what you are feeling as your weight. Likewise, when you are sitting, and then after that, when you're sitting, you will feel some sort of force through you between yourself and the chair. That is also considered as apparent weight. Apparent weight is just simply a force that you feel when you have a part of your body pressing down onto a surface. It could be when you're standing, it could be when you're sitting. That force that you feel when you're in contact with the floor or the chair is what you feel as your apparent weight. So when we ask you apparent weight, you just need to know that apparent weight is actually just the contact force. All right. For example, let me just illustrate to you. If you have a person that's standing here, your body exerts a weight downwards, the floor exerts a weight, a reaction force back upwards on you. This is what you will know as apparent weight. Okay. And likewise, when you are sitting like this, let's say you're sitting here like this, okay, you would exert a force down onto the chair, and then in return the chair will exert a reaction force back up to you. Again, this is what you know as your apparent weight. Okay, so whenever we mention things like apparent weight, it's actually talking about the contact force between yourself and some other contacting object. All right, so we are trying to determine the apparent weight of a person that is standing inside an elevator right now as he's going through different stages of motion. Now, when you have gone into an elevator before, you might have felt this kind of sensation. If let's just say your elevator is going up, let's just say this is you inside. If your elevator is going up, there might have been cases where you somehow feel heavier, like something is pushing down on you as the elevator is going up. And then conversely, when the elevator is going down, you also feel the sensation that you are lighter, right? So have you encountered something like that before? I mean, when you step inside an elevator, as the elevator goes up and then it goes down, there's a different feeling. You somehow feel heavier in some cases, and then you somehow feel lighter in some cases. No. Yes, no? Okay. Samir, are you there?
Sorry, sir, I couldn't hear you.
Okay, is there any static over the screen right now? I mean, you can hear my voice clearly?
I can hear your voice, but just now it was a bit of like not clear.
Oh, okay. Right, no worries. What I was just asking just now was that if you go inside an elevator, as the elevator goes up and goes down, there will be some cases where you feel heavier and some cases where you feel lighter. I'm not sure whether have you encountered experiences like that. Have you?
Yeah.
Yeah, so you sometimes feel heavier, you sometimes feel lighter. That is actually your apparent weight. What you are feeling that time is actually your apparent weight. And it comes about due to the reaction force between yourself and the elevator floor. So that's what we are trying to investigate right now. Okay. So right now you have 4 different cases. All right. I'm just gonna zoom out a little. Okay. So that it's easier to see. Now you have 4 different cases. You have a case where, let me clear off the things here. I'll just clear off everything here first. Okay, you have 4 different cases. The first one being constant velocity upwards, constant acceleration upwards, constant acceleration downwards, and then also constant acceleration downwards, but this time is at gravitational acceleration value. The one before this is at 3 meters per second only. So all these different cases here will cause you to feel different weights. You feel different apparent weights. So as I mentioned just now to you, your apparent weight is actually your normal reaction force. So right now, your weight, in the first example, your weight is acting down onto the elevator floor. In return, the elevator floor exerts a normal reaction force back up to you. Okay, so right now, because you're moving with constant velocity upwards, because you're moving with constant velocity upwards, that means your acceleration is 0. So even though you are saying that you're moving upwards right now, your acceleration is actually 0. So if let's just say I wanted to apply Fnet equals to 0, Fnet equals to ma, because my acceleration is 0, my Fnet is actually 0. Okay, so it will be W minus R equals 0. Eventually, R is equals to W itself, right? So constant velocity, acceleration is 0. If I try to apply the equation Fnet equals to ma, because a is 0, Fnet will be 0 based on this equation. And Fnet itself is based on these two forces. That time I mentioned to you, forces that are in the direction of your acceleration is positive. Forces that is opposite to your direction of acceleration is negative. So in this case, my mistake. This one will be R minus W. Okay. Forces in the direction of your acceleration will be positive. Forces opposite to your direction of acceleration would be negative. So over here, your R is just equals to W. So what you can say here is that you feel normal. You don't feel heavier, you don't feel lighter when your elevator is moving with constant velocity. But the second case here, you are not moving with constant velocity. You're moving with some value of acceleration, say maybe 3 meters per second. You're trying to do the same thing. This is W, this is R, okay? And then your acceleration is upwards at some value of 3 meters per second square. So right now, I try to use the equation Fnet equals to ma. Okay, my Fnet is not going to be 0 because I have some value of acceleration. My Fnet here is going to be R minus W equals to ma. My R is going to be W plus ma. So in this case here, your weight is being added upon by another thing equivalent to MA. So here you will actually feel heavier. If it was this case originally, you feel normal. You don't feel heavier, you don't feel lighter, because contact force is just equal to your weight itself. But in this second case here, because R is equals to W plus MA, your weight is being added upon by MA. You're adding something else to your weight. So obviously your R is going to be bigger. All right, here you can definitely say R is more than W already, because W is added on with something else. All right, so you will therefore feel heavier. This is what happens when your elevator is accelerating upwards. You feel heavier. Now, what if on the other hand, your elevator is moving downward with an acceleration again equals to 3 meters per second square? Same thing as before. Your weight acts downward, your normal reaction force acts outwards. If I try to use Fnet equals to MA now, over here, I will get this one where Fnet equals to MA. So right now, W is in the direction of my acceleration, so it's positive. R is opposite to my direction of acceleration, so it's negative. So it's W minus R equals to MA instead. You see, this one and this one are two completely different expressions, right? Simply because right now, whether you're going to get positive or negative depends on the direction of the force with respect to the acceleration. Okay, so this is what you have here. If you try to work out and make R the subject, R is actually W minus MA. Okay, so you notice now here, R is actually the weight minus off with MA. Obviously, your R is going to be less than W already. All right, so in this case here, you actually feel lighter. Okay, that's the reason why you feel heavier and lighter here in both cases for the elevator when it's moving up and then when it's moving down. Okay, the fourth case here is a bit special. It's still talking about you having a constant acceleration downwards, but this time your acceleration is actually equal to the gravitational acceleration itself. So when it's equal to the gravitational acceleration itself, I go down here, A is equals to J. All right. So I try to make use of the same equation as before. I look at the free body diagram first, or rather the forces that act on the diagram. I have weight W, I have reaction force R. So what I'll have is Fnet equals to MA, W minus R equals to MA, and then R is equals to W minus MA. Okay, now this one here, since you know W is equals to mg, and then A is equals to G, your resulting expression would actually be equals to this. Mg minus mg giving you 0. Okay, weight is mg, mass times gravitational acceleration, and then now we specifically tell you your acceleration is equal to the gravitational acceleration itself. So your resulting expression is going to be this, mg minus mg. You're going to get 0. So in this case here, this is where you actually feel weightless. You can't feel anything from the floor at all. It feels like you're floating when you actually aren't. Okay, so when you feel weightless, it's mainly because your reaction force from the ground onto you is actually 0. Okay, so this is application of Fnet equals to MA on something moving inside an elevator, right? This question does come out occasionally, so it's good to know this.